In this video, we'll begin our discussion of the different collections that are available in Visual Basic.net and the .NET Framework. Please note that this is a PowerPoint-only presentation, and also that this is the basis for all the other discussions that we'll have on the various collections that are found in the iDictionary and iList interfaces. So let's start off by defining collections. Collections are basically groupings of objects, and these objects can be simple objects like integers or strings, or they can be very complex objects like your custom classes. And so what we'll do in our examples is use a custom class called car with a couple of different properties, and we'll have collections, different collections of cars to see the properties of those collections and what they can do for us. And so that gets us to the next point. In Visual Basic 6 or other programming languages, you might have had two or three different options on how to gather together all of these different objects. In .NET, you have tons of options, tons of different collection objects that you can use, and the ones you'll select will be based on how familiar you are, first of all, with them, and that's kind of the impetus behind this whole series of videos. But what you should be basing your decisions on are things like memory overhead, what do I want to accomplish with this collection of objects, how much searching through it will I need to do, will I need to sort, and other things like that. But despite whatever collection that you actually choose, they all have one thing in common, and that is that they all derive from the iCollection interface. I know we haven't talked about interfaces up to this point very much. We haven't had a need to, but now we're going to get heavy into interfaces. And basically, interfaces are contracts that objects must agree to in order to say that I support or I implement a given interface. And so an interface is simply a definition of properties and methods and an implementation of those properties and methods within a class. You can't use the interface by itself. You have to implement a class that derives from or implements that given interface. And the benefit is that you get polymorphic properties. In other words, if you have two objects that both implement a given interface, but they have additional properties and methods, the fact that they both implement the same interface means that they can be used interchangeably to some extent within your code. So what does that mean to you? Well, all collections will implement certain methods and properties. That's what makes all collections basically the same. However, they have additional methods and properties that make them unique and will demand us to really understand how they're implemented behind the scenes in order to get the greatest amount of advantage from one collection versus another. So the iCollection interface has only three properties and one method that every collection has to have in common. But as we'll see in a moment, very few collections actually implement the iCollection interface. Instead, what you'll see is that there will be two other interfaces that implement iCollection that all the collections that we care about will actually use, and that is iList and iDictionary. So in other words, iList implements iCollection and iDictionary implements iCollection. And there are several collections that use the iList, and whenever you're dealing with the iList collections, think indexers. Think something to the equivalent of an array. In fact, array is one of the collections that implement iList. And then there's the iDictionary, and whenever you think of a dictionary, almost like what you used in VB6, think key value. And so there's several collections that derive from iDictionary as well. So let's begin by taking a look at the iList interface, and our little motto for the iList is think indexers. And indexers, just to be clear on this, are the actual numerical values that allow us to iterate through the different items in the collection. So for example, if you have a collection of 3 items, you can access the second one by using the 1 element. Now this is different, markedly different from the way that iDictionary works when you're working with a non-ordinal, non-numeric potentially value for the way that you get at the values that are inside the collection. So it's really important to keep those distinctions in your mind because that's going to affect which of the collections that you actually choose. So as we take a look at some of the properties and methods, keep in mind that as we go into each of the examples in in the videos that will follow this that will look at each of the properties and methods in greater detail and show code examples for each one. But here let me give you an overview of every collection that implements iList, some of the general properties that they share in common. For example, it has three properties. The first one is fixed size. That allows you to tell if that given collection can have any additional elements added to it or not. And then the other property is read-only, and this allows you to tell if any of the existing elements within a given collection can be changed or if they're read-only and cannot be written to. And then the item is what we'll use to actually use an indexer to access a given element of a collection. So we would do something like myCollection.item and pass in a sub of 1, and we would be able to get values from that or even set that value equal to something else by using the item property. It has 7 methods that are implemented by iList. The first one is add. It allows you to tack on a new element to the end of the collection. And insert allows you to tack on a new element but at a specified location within the collection. The clear method will allow you to remove all of the elements in a given collection, just totally wipe it out. The remove will give you the ability to use an indexer to specify a specific element of the collection that you want to get rid of. The remove at will say, okay, from the third element and everything after it, remove them all. And so it gets rid of everything from a given element to the very end of the collection. The contains method allows you to check and see if an instance of an object exists within your collection. So you can see if a given car exists within your collection, as we'll use an example in future videos. Or instead of getting the actual object back, you can get just the index of where it appears in the collection by using the index of. Now the important thing to remember is that iList is just an interface. You cannot use iList by itself. However, there are 3 collections that, well actually there's more, but there's 3 important collections that allow us to use and gain benefit from the iList interface. And the first one is array, and the array is the most simple, lowest overhead of all of the iList collections that are available. It allows you to add a strongly typed group. In other words, everything in that array has to be of the same type unless you create an array of objects, which we'll talk about later. The difference between the array list and the array is that the array list is a little bit more flexible. Not only can you manipulate the size of the collection much more easily than you can in the array, but also you can add different types of objects more easily than you can in the array. And then finally is a really unique little collection called Q. And Q has the mindset of FIFO, which is first in, first out for those who are in operations management. So anything that comes in will be the first thing that goes out whenever you are iterating through the queue. And this is used for things like message queuing or whenever you use memory or file streams. It's a very important collection to use in those cases. So let's continue on and take a look at the iDictionary interface. Our little motto for the iDictionary interface is think key value. So whenever you're accessing elements within collections that implement iDictionary, you won't use an indexer like a numerical indexer like we just talked about with the iList. Instead, you're going to use a key value, and that key can be a string value, it can be an object, it can be anything that allows you to uniquely identify that given item from all the other items that are within the dictionary. And so just like we did for iList, let's take a look at the properties and methods that any collection that implements iDictionary must have or must implement. And some of these are going to look very familiar, so we're not going to take the time to go through each and every one individually. Is fixed size, is read-only, just like the ones we talked about last time. The item, it allows you to index into the dictionary, but the difference is when we use an item with the iList, you use 0, 1, 2, 3. When you use an item with the iDictionary interface, it is actually the key value. So you also have then two properties. One should be keys instead of key, and then values. And these are two collections, and in and of themselves, a collection of keys and a collection of values, so that you can iterate through and find the fifth key, and it should equal the fifth value. So just another way to tap into the dictionary and get information out. Then there's 5 methods that are implemented. Again, some of these look very familiar, like the add, clear, remove, contains. The get enumerator is special in so much that it allows for custom enumeration through your dictionary. So say, for example, that you have your own custom component or custom class, and you want to specify the way that the dictionary can enumerate through all the elements within that collection. So you create a custom enumerator. And although that's pretty advanced, we are going to get to that in about 10 videos from now. So just hang on for that thought. And just like we said last time about the iList, how you can't really use the iList. You actually have to use something that implements iList. Same thing is true with the iDictionary. You can't use the iDictionary by itself, but you can use a collection that implements iDictionary. And so there's 4 popular collections that implement iDictionary, and they are hash table, and list dictionary, hybrid dictionary, and sorted list. Let's take a look at the hash table first, because it's the probably most popular and has the most functionality of any of the iDictionary implementing collections. The hash table uses a hash table algorithm to store the values internally. Now what that means is that there are a number of buckets that are set up. And if you think about the term hash, if you ever use the expression, we're going to hash through this, we're going to sort it out, that's kind of the same thing. That internally what happens is a bunch of buckets are set up, and those buckets represent a numerical range like 0 through 10, 11 through 20, 21 through 30. And I'm oversimplifying this for any of you who really know this stuff. Please understand, I'm doing this for illustration purposes. But when you add up all of, let's say in a given collection we use as a key the word Scott. If you add up all the ASCII equivalent values for Scott, it'll add up to a certain number. So you would put that Scott into a bucket that was between, let's say, 130 and 140. So that in the future, whenever we're looking for Scott, we can go directly to the 130 to 140 bucket and then look through each of the items there and then grab out the given item. Now there's this other concept called the fill factor, and that allows us to define how many items can fit within a bucket before a new bucket has to be created. And this is really a pretty deep computer science topic. It's implemented at a pretty low level, so we're not going to get into the actual discussion about that. But this will help us understand the distinction between the hash table and some of the other ones that we're going to look at in just a moment. So in other words, whenever you think of hash table, it's important to think that there's this whole infrastructure that gets set up in memory, and therefore it's more appropriate to use that whenever you have more than 10 items within your dictionary. Now let's contrast that to the list dictionary. The list dictionary is set up as a simple list, a sorted list, or I think a linked list, I think they call it, and that means it's going to go one by one through every item in order to find a given element within that dictionary. So it requires a lot less setup to begin with, so you don't have to implement all these buckets in memory. But whenever you get to a certain size, it's not practical to count from 1 to 1,000,000 and find the 999,999th item in the list. So you wouldn't want to use the list dictionary with any item with any collections that are greater than 10 elements. Now there's a unique third option, which is the hybrid dictionary, which takes the best from both worlds. Think of metamorphosis whenever you think of the hybrid dictionary. It starts out as a list dictionary, and then as it grows, it becomes a hash table. So there's something that whenever you get to the 10th element, you add the 11th one, or something along those lines. It's going to be pretty much in that ballpark. it will change from a list dictionary and go ahead and set up the entire hash table in anticipation that more items will be added to it. So you get the benefits of, at the very beginning of the use of the hybrid dictionary, the benefit of the list dictionary, keeping it small, very compact, very small in the memory space, very fast, and then as time goes on and you add more items to the dictionary, it expands out and it gives you the performance benefits of the hash table. And then there's the final one is kind of an odd dictionary, and that is the sorted list. And the sorted list is a cross between the hash table and an array. And what it allows you to do is access items in the collection either by their numerical indexer, just like you did in an array 1, 2, 3, 4, 5, 6, or by their key within the collection. So it could be Scott, Bob, Steve, Jim, whatever the case might be. So it gives you options in that regard. Now, you're going to pay a price for that. There's going to be a performance hit that you take by maintaining all this, the extra infrastructure to support both the iDictionary and elements of the iList as well. So you may not want to use that if optimization is your key. But if you're just for pure convenience, the sorted list is actually a pretty good way to go. So before we continue on, I just wanted to bring some things to light that are on my mind, some random notes on collections. You want to choose the right collection for your particular needs. Being lazy is really not a good idea, because if you're doing a lot of looping, you should choose the right one, or it's going to affect your the performance of your application. So there's some elements that you're going to have to balance. Now that we've talked about the different advantages from the different types of collections that are available, you need to balance the speed, the speed of accessing, the speed of adding, all those kinds of things, the system resources that you have available, your own particular coding style, how you like to access things within your code. Now that speaks to laziness a little bit. And then finally, what's appropriate for this given situation. So you need to balance those and understand that you have more than just a hammer in your toolbox, that you have lots of tools, and you should choose the correct tool for a given situation. The other thing that I really wanted to bring out to light is that you can store different types in a collection. Now this isn't true of an array, but it is true of the other types of collections. For example, we're going to talk about and show how to create a car object and a truck object that have different properties and different methods, but they can both be added to the same autos collection, even if they don't implement the same interface. Now in the next version of .NET, there's going to be this concept, I don't know if they're calling it templated collections, but it's something along those lines. And those are going to allow you to enforce type-safe collections a lot like how arrays are type-safe. So that's something to keep in mind for the future. So let's take a look at how you sort elements in a collection. Basically, it's different for each of the two major types of collections. The iDictionary is automatically sorted by the key. Now, when I say that, I'm not suggesting that it's necessarily sorted in alphabetical or numerical order. It's sorted however it's internally implemented by the iDictionary object, which means you can't always count on a collection that implements iDictionary to give you back things in a sorted manner. The iList is automatically sorted by index, 0, 1, 2, 3, 4, etc. But as far as both of these are concerned, the most important thing to remember is that you can create a custom sort based on the value of the items that are within your collection. So if you have a values that are objects, you can create a interface in each of your objects called iComparable, and what it'll force you to do within your code is to create a method called compareTo, and that method will need to return back whether two objects of a similar type are equivalent to each other, not equivalent to each other, or one's greater than the other one. There's a whole bunch of rules that go in there, and we'll show you how to do that in a video about sorting collections. But keep in mind that you can custom sort items that are within collections based on some criteria that you create for the objects. And I guess I got a little bit ahead of myself here. What we'll do in our examples are use the idea of a car, and a car has a model, make, and year. What if I want to sort by the year, or do I want to sort by the make? So I can implement within my car class, I can implement the iComparable interface, which will require that I implement the compares to method, which will help decide if I want to sort by the year property or the make, and I'll be responsible for that on my side. Because quite frankly, the collections have no idea how to work with objects that they're not familiar with. The strings, integers, those have the equivalent of an iComparable interface built into them, but your objects need to implement that so that they can be sorted properly. But what happens in the case where you have multiple objects of different types that are within your collection? How do you sort those? How does your class, your car class, know how to compare itself to something of a truck class? Well, you really can't. In that case, you need to implement a different interface called comparer. And it's especially useful in the two cases. The one that I already described, which is listed, I believe, as the second one, when one or more of the classes or the objects that are stored in the collection are not of the same type. So that's where you would implement the iComparer interface. And it also has a benefit whenever maybe you have a third-party component, one that you've purchased, but the vendor has sealed the classes, which means you can't derive from them, you can't add on any additional information that would allow you to implement the comparable interface. In that case, you need kind of a third-party sorting object that knows how to take in objects of different types and evaluate those different objects based on some criteria. So you might compare the car based on its year property, but you might then compare that to the truck on, oh, I don't know, the year of the tires or some other property that's implemented in that class. And again, we'll demonstrate how to use the iComparer interface to compare two objects of different types. And then finally, when we're talking about sorting, we'd be remiss if we didn't mention that you can also reverse the order of the collection using the reverse method that is implemented in many of the different collections. Obviously, one of the big things that you'll want to do with a collection is actually go through each item in the collection one by one, and that's called enumerating. And we've talked briefly about enumerating. We talked about the getEnumerator method that returns back an instance of an enumeration object that you implement for your custom classes, and that's really what we're talking about in this second point here. When you're dealing with dictionaries, you'll need to do that. Well, why do you need to do that? Well, because your collections inherently don't know how to handle your custom objects, your custom classes. It will need some instruction on what is the correct order to iterate through each of the objects within your collection. That is unlike the point above it that I make with the iList. You can simply use the indexer, the order in which you added them into the collection to begin with. So you can use item 0, item 1, item 2, and that's how you can enumerate through them. Of course, you can enumerate through both the iList and iDictionary interfaced collections by using, and what we'll use most often, the for each method. And finally, some of the collections, not all of them, allow you to manipulate groups or ranges of elements within a collection. And this can be used to manage more than one element at a time. So you can insert a group of elements in a specific spot, or add a range or grouping of elements to the very end of a collection. Or you can remove a whole group from item 3 through 7. Get rid of all those items. You can also set and get ranges, which allow you to, in the case of set, it allows you to basically overwrite the existing items that are within that range of the collection. And then the get allows you to just specify a given range, and that range can be pulled and inserted into another collection. And we'll show you an example of all of these in a future video. And then obviously with a sort, the sort has some of this ability to manipulate ranges of elements. You're able to sort just a section of your collection, not the entire collection if you so desire. So a lot of these kinds of things are nice to haves. I don't know how often you'd actually, for example, sort a small range of your collection without sorting the whole thing, but they're available as tools for you so that you can get the most out of your use of collections. So I hope